into that is polynomials. Okay, now in this part, here we are going to discuss about the polynomials. Before going to that, before introducing that the polynomials, we need to know what is the polynomials first. This definition of the polynomials we'll finish to read from that in the class 8. So, what is the polynomials? I think you know that. Polynomials is the one of the mathematical expression in which non-negative power, isn't it? If any variable have their non-negative power, just like as, for example, suppose f x equals to, there I'll write that is the 3x cubed minus 2x plus 1. Then it is called the polynomials. So in this case, here the variable's power it will be that is the 3 here, and here will be the 1, isn't it? Variable power is the 1. But in this case, there isn't that's a negative power. It means that the polynomials means the mathematical or algebraic expression in which the variable power must be that is the whole number. Whole number means that is the 0, 1, 2, 3, 4, same like that. In this case also, here is a 1, its variable power will be the 0, same like that. Isn't it? So if the variable power it will be that is the whole number, then we can say that it is the polynomials, isn't it? But now in this class, then we can take the help of that is the definition of the polynomials to memorize or to write that definition of the remainder theorem and the factor theorem. For the remainder theorem and factor theorem, we must have to understand that is the definition of the polynomials. Okay, we go to the last one again. Now, remainder theorem and the factor theorem. Check it now. I'll go to that in the remainder theorem. Okay, first that remainder theorem and the factor theorem is one of the very important theorem for the polynomials. Okay, let's we discuss about that one. Check it out. First, remainder theorem. What is the remainder theorem? Now let's we discuss. Remainder theorem. Okay, check it. What is the remainder theorem? In this remainder theorem, first I'll write that is the first in this part here. Suppose we divide something polynomial here. The x minus 2 is here, and it will be divided that is the x square minus 2x plus. Okay, that is the 1. Yeah. Okay, this will be that is the in this case here we have to write that is the terminal over here, that is the 3x. Okay. 3x plus 1 is there, and now here we have to divide it. So now, check it. If this is called a particle method, if we divide this one by this 2a, then here we have to write the x, and this will be x and x, that will be the x square, and now that's minus 2x. Minus 2x. Now it is the, we have to change the sign, minus plus. Now check it. This will be cancelled out. x and x, and we have to remain here, that is the minus x, and plus 1 is done the down over here, and same again, we have to by that. So here will be a minus is not enough to get to that is the minus x. So minus and minus, that is the minus x, and minus minus, that is the plus, that is the 2 into that is the 1, that will be a 2. So here we have to write this is the plus and this is the minus sign. So that x and x cancel out, we get the minus 1. This is called the remainder. This minus 1 called the remainder, isn't it? Now same question here in this part, we still have the divisor, dividend first. Dividend. Okay, now in this case, we write the dividend. Dividend as that is the x squared minus 3x plus 1, and the divisor. Divisor as that is x minus 2. And suppose this dividend we call as the fx. Suppose, okay? Okay, this dividend we call as the fx. Now, from this part, from this divisor, if you look over here, if you write that is the x minus 2 goes to 0, we get the value of the x as that is the 2. Okay. Now, once you substitute the value of this one x in the this one polynomials in the dividend, what you get? Check it out. Here, when x equals to 2 at the time, you get here as the f2, and now here is the 2 square minus 3 into 2 plus 1. Now what do you get here? Here we get the answer. Now this will be that is the 4 minus that will be a 6 plus 1. So what we get? Here we get the answer, that's a minus 1. So this is also called the remainder. This is also called the remainder. Now one time you can tally this one answer and this one answer. So both of the answer. If you take this both of the answer over here, if you take the both of the answer this one over here, you get the same. Sorry. From the vertical part also you get the remainder, that is a minus 1. And from by substituting the value of the x in the given polynomials, you also get that is the minus 1 over here. Sorry. Remainder as the minus 1. So one thing, whenever you are going to find out the remainder of the any polynomials, whenever it is divided by the any polynomials at the time, now we still need to use that vertical method as well as the synthetic division. In this case, we can able to find out its remainder by substituting the value of the x in the given polynomials. Okay. So now in this part here, if you put the value of the x as the minus here with 2 over here, you get the same remainder as the minus 1, same like as in the vertical method, isn't it? So remainder theorem tells the same like that over here. Remainder theorem tells the same like that over here. So, suppose here is the one of the polynomials you are given here as the fx equals to x squared minus 3x plus 1, isn't it? Suppose in this case, here the polynomial is f2. Once you check here, this f2. f2 gives that is the remainder as the minus 1, isn't it? f2 gives the remainder as the minus 1. Same like that, whenever this polynomial is divided by the x minus 3, at the time, its remainder after this one is given by the same like that, that is the f, that is the 3. Same like that this one. Okay? We can find out the value of the x from this one divisor. Whatever we get the value of the x, we just substitute on the given polynomials. and whatever give the answer, that is called the remainder of the that polynomials. You get it? Again, I'll give an example. Suppose if you divide this above one polynomials, if this polynomials, if this polynomials you divide by the x minus 9, okay, x plus 9, what part it gives the remainder real? Okay, so we know that from this one you get the value of the x as value of the x will be, that is the minus 9. You get a value of x as minus 9. So its remainder will be given by that is the f minus 9. Isn't it? This is the same here. Okay? Same idea. If you divide this terminal, that polynomials is divided by the x plus 5, then its remainder will be given by the suppose here will be x equals to, that will be a minus 5. Isn't it? Minus 5, so its remainder will be given by the minus 5. So this is the one of the symbol which is used to find out the remainder of A to B. Okay, this is the same formula which is given by the remainder theorem. Okay, so now I'll give the definition of the remainder theorem. What is it actually? Okay, now take it. Remainder theorem definition. Okay, remainder theorem. This is a very important theorem for example. Remainder theorem. Okay. Okay, definition. Definition is that if the polynomials fx of degree greater than 0 is divided by x minus a, then f a gives the remainder of polynomial, remainder of fx. Okay, we can write here known as remainder theorem. Okay, this is the part over here. Okay, now in this part, in this definition, we can say that here is the if the polynomials fx. Suppose one polynomial it is defined over here. That polynomial is this one fx. One polynomial you have as the fx whose degree is not equals to 0. It is the greater than that is the 0. It means that the polynomials in this case for the remainder theorem we have to take the polynomials it's greater than that's the 0. It must be start from the 1, 2, 3, 4, 5, 6 something else like as a natural number. Okay, so now the main point on this definition on this part is you must have to mention here degree greater than 0, not equals to 0. But in the polynomials already needs to define here. Polynomials will be that grammar power must be whole number over here, isn't it? So, but in this remainder theorem, we have to take that the its variable power is the only greater than equals to 0. Okay, so now is the divided by this one. This polynomial fx is divided by the x minus a at the time. At the time, I will tell you that whenever this x minus a is given to you, its value of the a will be value of the x will be, that is the a. So now obviously it gives the remainder of this one as the fa. Same terminal is given to you. So whenever this fx is divided by the x minus a, at the time its remainder will be given by this fa. So fa gives the remainder of, that is the function fx. Sorry, that is the polynomial fx. You got it? Okay, this is the one of the very important definition of the polynomials. You got it? There we have the two definition, two theorem, one remainder theorem as well as the factor theorem. Okay, this is the remainder theorem. Okay, now I'll start that is I'll go to the next one theorem, that is the factor theorem. Check it out. Okay, for the factor theorem, check it. What is the factor theorem now? Factor theorem. Okay, now in this factor theorem, now first of all, in this part here we have to take some example first. Okay, now 6. Suppose we divide the 6 by the, that is the okay, now that is the 7. If we divide the 7, 6 is enough. 6 is to give for you. Okay, if you take that is the 6 as the one of the factor, okay, then factor of the 6 will be now again. Okay, now 6. Okay, 6 is here. Okay, now it is the, we have to write. We know that factor of the 6 will be. Factor of the 6 is, that is the 1, 2, 3, as well as that is the, we can say that is polynomial. So now in this case, the factor of the, that is the 6 should be that 2 is also be the one of the factor. So, write the 6 also. 2 is the one of the factor of that is the 6. Because whenever we divide it here, we get the, it will be 3. It is exactly divisible. The remainder will be the 0, isn't it? So we can set up the 2 is the one of the factor of this 6. So in this part here, we have to write 2 3, that will be 6. Here we have to write minus, that will be remainder will be the 0. We can say that the 2 is the one of the factor of the 6, isn't it? From this example, we get the conclusion that to be or that is the factor of any number, the remainder of it must be the 0. Again, to be a factor, if any number to be a factor of any constant term or any constant number, whenever it divides here, its remainder always must be, that is the 0. Isn't it? So by that question over here. So same terminal over here. Suppose here, if I take that is the one of the polynomials, that's a 3x cubed minus 1. Suppose it is divided by the x minus 3. X minus 3. Then its remainder is given by, its remainder will be given by, that is the what? That is the f3. F3 will give the remainder of this polynomials. F3 will give the remainder of that polynomials. So to be a x minus 3 as the factor of that is the fx, its remainder must be, that will be the 0. You got it? So whenever the polynomial, this one polynomial fx is divided by the x minus 3, If its remainder as that is the f3 gives the remainder, if its remainder will be the 0, then we said that the x minus 3 is the factor of the polynomials that's fx. We get it? So one example, I'll give that one example to you. Check it out. Okay, that is the okay, one example is
Visa 1 million.
okay. Okay, now check it. Suppose one polynomial you have that is the fx equals to okay x square minus 2x 2x plus 1, and now it is divided by the next one that is the zx polynomials by that is the x minus 1. It's a divided. Suppose this is the divided here. Fx is the divided by that is the zx. Okay, in this case, check it now. In this case, here we have to divide. If we divide, then now what I substitute the value here? Here, x minus 2, x minus 1 is given to you. Now the x minus 1, we get the value of the x as the 1. So now, in this part, here if you substitute the value, the remainder of this one polynomials is given by when it is divided. It gives the remainder by the that is the 1 over here. Really? So f1 gives the remainder of the given polynomials over here. This one polynomials. So substitute a value here. 1 square minus that's a 2 into 1 plus 1. So we get the 1 minus 2 plus 1. So this all will be cancelled out. So the remainder will be 0. So in this part here, it gives the remainder as the 0. Isn't it? It gives the remainder after that the fx f1 gives the remainder as the 0 over here. In this case, we can say that now since f1 equals to 0, f1 equals to 0, so x minus 1 is factor of x. Like that we can say. Okay. Since here if the f1 gives the remainder gives the as the 0, it is divided by this part over here. Fx is divided by 0. In this case, the divisor. This one is the divisor. This one. X minus 1 is the divisor. This x minus 1 we call that factor of given polynomials. That is the polynomial fx. This is derived as the factor. You got it? Okay. Now I'll give the definition same like that. Okay. Now here. Now check it. Factor theorem. Okay. Okay, factor theorem. Check it. In this factor theorem, now same like as the previous one, we can say that in this case also, in this way also we can write the factor theorem state that definition here first. Definition. Factor theorem Factor theorem states that factor theorem states that if the polynomial fx of degree greater than 0 is divided by x minus a, x minus a, x minus a, x minus a, and fa gives the remainder, isn't it? Fa must be that is the 0. If fa equals to 0, then 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 x minus a is factor of polynomial fx, factor of fx. Okay, this is the definition of here for the factor theorem. Factor theorem states that if the polynomial fx of the degree greater than 0, it's up to here, it's the same like that. Degree greater than 0 is divided by the x minus a. Up to here. Up to here, that is the definition of the factor theorem and the remainder theorem is the same over here. But one new part for this one is here. Here you must have to memorize this one. To be a factor of any polynomial, the remainder of it must be that is the 0. So fa equals to 0 is given to you. So that remainder of this one polynomial, whenever this fx is, whenever this one fx is divided by x minus a, obviously we know that its remainder is given by fa. So fa remainder, if it will be 0, then we can say that x minus a is the factor of that fx. X minus a is factor of fx. This is the factor theorem. Okay, this two theorem, the remainder theorem and the factor theorem, that is the definition. It's a very, very important. Maybe in the first topic then this one that definition will be asked in exam. So this is very important. So that is a very, very important. Okay, by taking the help of this remainder theorem and the factor theorem, now we are going to solve some question over here. Check it now. Okay, check it. The first question. When okay, when the polynomials when the polynomials polynomial fx equals to 3x cube minus 2x plus k plus k plus k is divided by x minus 2, then x minus 2, it's leaves the remainder as 7. Then find the value of k. Oh, this is the question. Now we find out the value of the that is a k by using the remainder theorem over here. Second one. First, in this case, you are given the answer one polynomial, so it will be a okay. Solution. Here we are given to you as the polynomials. Polynomial that is fx equals to that is a 3x minus 2x plus k. One you are given that is the one that the factor divisor as the x minus 2. You know, divisor as the x minus 2. So in this part, in this case, we can use the okay, remainder of this one is given to you as the now f2 gives the remainder of the. So now in this part we can use the remainder theorem. Okay, for that we can just compare it. Comparing the x minus 2 with x minus 8. X minus 8 and then constant term. Constant term a equals to, you can say that whatever its value is given to you here, we can write here we can write x minus 2 is given to you. So its value of the x will be that is 2. So value of the a will be that is the, we can write here as the 2. Same like here, the value of the a means value of the x. So now if we substitute the value now, okay, now by using remainder theorem, that's that's 2 equals to its remainder. Check now. Its remainder we can say that whenever this polynomial fx is divided by the x minus 8, it leaves the remainder as that is the 7. So f2 gives the remainder. So we can write instead of that is the f2 we can write here that is the 7. It's the remainder. Now after that we can substitute the value here. We can substitute the value here. Okay, we substitute the value that is the f2. Okay, f2 equals to that is the 7. Now we substitute the value. Okay, we substitute the value here. Okay, we substitute the value now. That's f2 equals to the right over here, that is the 3. Okay, 3 into that is the 2 cube. We can write in cube minus 2 into that is 2x 2 into 2, that is the plus k, and now it goes to that will be a 7. So now after that, here we can write that's the 8, 24. Now minus that is the 4 plus k equals to 7. Now after that, we can write this to be a 20. Now k equals to that is the 7 minus that will be a 20. So we can write it's the value of the k. So the k equals that is the 30. That's all. That is the minus 30. Yes, right. That is the minus 30. Okay, minus that minus that is the 30. Okay, let's read right over here. Okay. Okay, now second here. You get the value of the k equals that is the minus 13, isn't it? So now in this case, in this type of equation, anytime here, if you are given the remainder over here, always we can put up at the remainder we can put that as the value as that is the 7 over here. Send that in the question. If you given the as the remainder, then we can put the 7 over here to find out the unknown value. Okay, but sometimes you are not given the remainder. Okay, you are not given the remainder, and the other time again you need to find out the unknown value. At that time, my one piece for you that very important piece that one is that if you are given the remainder, same like that, same like that, 7. At the time we can write like that, whatever given the remainder will be here. Okay, but sometimes if you are not given the remainder, and by the question it's tell you that have to find out the unknown value. At the time, instead of that 7, you can substitute the 0 here. Okay, there is a different types of language is given in the question. Sometimes you are given the it's a zeros of exactly divisible roots of something terminal is given to you. If you didn't understand any question at that time, you can mention the f2 that will be equals to 0 in that case. You got it? If the remainder is not given to you, if the remainder is given to you, it's no problem. We can mention just like over here. If the remainder is not given to you, at the time we think it as 0 is the one of the remainder or it's exactly divisible something else. If you have to find out the value of the k, you must have to write like that. You get it? To find out the unknown value. Okay, now I'll give the next one example also. Check it out. Okay, one example. Now, suppose you are given if I prove that prove prove that x cube prove that x minus 2 is the factor of prove that x minus 2 that x minus 2 is factor of the polynomials factor of polynomial x cube minus 19x plus or okay, now check it. Now in this case, here you are given the prove that x minus 2 is the factor of the polynomial x cube minus 19x plus 4. Now how we prove that this one? I prove that this one x minus 2 is one of the factor of this one polynomial. That is the question. Check it now. First, in this case, to prove that this one polynomial, this x minus 1 is the factor of this one, we must have to take the help of the arithmetic theorem. Same here. If we prove the remainder of this one polynomials, whenever it is divided here, its remainder is 0, then this x minus 2 is the one the factor of this polynomial. It's quite simple, isn't it? So before that, in this case, in this polynomials, you are not given the, you are not mentioned that there is any naming over here, like as fx, gx, something else. So our main job in this part here is first you must have to let this polynomials as the fx, gx, anything, whatever you like. So now in this case, I'll let the first. So let gx equals to x cube minus 19x plus 30 be given polynomial. Okay, then now here we can write. Now here is the x minus 2 is the one of the factors, so we can compare. So comparing x minus 2 with x minus 8. Constant term a equals to, now what's the value of the x in this part? Value of the x will be here, we can write that is a 2. So here x equals to, we can write that is a 2. So now by using remainder theorem, by using remainder theorem, now in this part, if we use the remainder theorem, now in this case, here we can write, okay, that is the, we put it as the value of the, okay, we still need to write the remainder theorem over here, without substitute the, we still need to write the remainder theorem in this case, because we are not going to find out the value of the, so in this part, we just substitute the value here. So now in this part, if we substitute the value here, that is the f2. Okay, that is, if you substitute the value, that is the f2 over here, f2, then we get a value whatever here. Check it out. Now here, if you substitute, that is the 2 cube minus 19 into 2 plus 30. So now what do you get? That is the 8 minus that is the 38. 38 plus that is the 30. So we can say that here will be a 38. 38 minus 38. So this one the real and this will cancel out. So we get a value as the 0. So we can write at last here as the since remainder, that is the f2 equals to 0. So x minus, what is our divisor here? That is the x minus 2 is the divisor. So we can write x minus 2 is divided, x minus 2 is x minus 2 is a factor, factor of x. Yes, guys. Okay. Like that, we check that in whether the given divisor is a factor of the given polynomials or not. We can check like that. So to divide or to verify the given divisor as the factor here, the remainder of it must be that is the 0 here. If its remainder is 0, then we can say that it's a factor of it. You get it? Okay, this is the one question. Okay. Okay, now this is one example, and now another question is already again as the last one question to the class. Check it out. Okay, suppose if you are given if if that 3x minus 2x plus 1 equals to x minus 2 x plus middle then find question x and okay. Now this is the one of the equation you are given here. You can find, you can see the other. This one is the one of the equation, right? Okay, this is the one of the equation. This is the one of the equation you are given. Okay. So now 3x cubed minus 2x plus 1 equals to x minus 2, and the qx plus r. So now, before finding that is the question and the remainder, first of all, I'll find that the one formula. I'll give one formula for you. Check it out. Suppose here is the 3, okay, that is the 2, and it's divided by, it's divided by the 7 over here. What we get? Here will be a 2. 2, 3, that is the 6 over here, and that will be remainder is the 1. Remainder will be that is the 1 over here, so that is we can write here. Sign in after that 1. So in this part, this is called the remainder. This is called the question, and this is called the divider. This is called the divider. So now in this case, if you want to check that whatever we divide to particular way is correct or not, we can check like that. Suppose this 7 must be given by the, that is the 7, it will be equals to, that is the factor. Divisor into question, that we should get that is 3 plus remainder is that is the 1. What we get? 7 equals to 7. Now, in this case, look, once you look at this one part, in this case, this 7 we call as the, that is the polynomials or dividend we call. This 2 we call, that is a divisor. This 2 we call divisor. And this 3 we call, that's the question. And 1 we call the remainder. So by using this one over here, we can mention that one formula over here. So now that's a dividend. Dividend equals to 2 is the divisor, so divisor into quotient plus remainder that's the remainder. Okay. This is the one of the very important. This is the one of the very important formula to know that is taking the any polynomial whenever we divide it's correct or not over here. So that is the dividend equals to divisor into quotient plus remainder. So now in this case, to find out the remainder in this given question, to find out the remainder as well as the question, here we need to know that which one is the divisor as well as which one is the dividend. We must have to clarify first it over here. To find out or to know that the divisor and the dividend, we must have to compare this given equation. This equation we must have to compare with this formula. By using that, we find out first we find that the divisor and the dividend are first. And after that, by using the synthetic division, we find out the question as well as remainder. And one note I give to you that from this one question, whenever you have to find out the remainder only, at the time you use the remainder theorem. You get it on to find out the unknown value. And whenever we have to find out question as well as the remainder, at the time we must have to use the synthetic division. You got it? Okay, now going to solve this question. Okay, okay, now second. Now here we take this first. We take the we here you are given one equation here. Solution first. Here you are given here that is a 3x cube minus 2x plus 1 equals to that is x minus 2 and 2x plus 3. So in this part, we can comparing above equation with now divisor dividend that we call it is called fx. Fx equals to divisor into question plus remainder. Okay, if you compare with this one equation here, this one equation over here, your dividend will be dividend. You get dividend. Then that is the fx equals to we can say that the 3x cube minus 2x plus 1 and the divisor we can say that is the x minus 1 or x minus 2. After finding that, we can use the synthetic division over here. So in this part, the constant term will be here from the divisor we get a constant term. Now the constant term that is we can say that a equals to what we get that is the 2. So now we use the synthetic division over here. Synthetic division over here. So now, okay, by using synthetic division, again, by using synthetic division, by using synthetic division. By using synthetic division now in this part, okay. So to use the synthetic division here, you must have to take a number first, constant term. Here, in a given polynomials, you are given the fx as the this one fx we can mention just like as the 3. If it is to now in the class 9 also, here we must be the that in the variables power in the order. That's the 3 plus x squared is not given, so we must have to add this one term as the x squared and minus that is the 2x plus 1. Okay, this is the part. So we can take it as the value. Focusing on the order term here. Okay, that's the 3. That is a 0 minus 2 as well as plus 1. Okay. So now we can make one box here. Same here. That's constant term we get added. So we write a constant term. That's value of the A here. This one is the value of the A over here. So this value that the 2 we must have to mention here. So now here this 2, this 3 will be come down with the A. So we can write 3 as it is. And after that, now we can multiply this one 2 and this one 3 over here. Multiply the 2 and the 3, we get the 6. That 6 we have to write over here. That's 6. So if you do the add and subtract on the basis of that the sign given there, so that will be the 6. So now after that, again we have to multiply this 2 and this one 6. If you multiply that 6 to that, that's the 12. Okay. So now that 12 again we have to add and subtract, what we get? That is 10. Now again we multiply, that is the 10 and 2, that will be a 20. So we get a 21. If you add and subtract. Now look at the terminal here. Whatever in the last form is there, this we separated it by one box over here. This we call the remainder. This we call the remainder over here. And now in this part, we can say that the factor. Okay, that's the remainder. Question we can write now. Question we can write. Okay, you can represent. You can symbolize it by the figures also. We can write what over here. Okay, we have here is the year power, that the variable power is the start from that is the cube. So we have to minimize the one power over here. So we can write, we can start from the square. 3x square plus 6x plus 8. This is the question. And our remainder will be a that is the R will be now what will be here 21. Okay, like that. By using the synthetic division, we can find out the question as well as the remainder theorem. Now, from today's class, you can able to solve all the short question. Okay, you can able to solve all the short question after this polynomials chapter, polynomials unit over here. Okay, thank you class. Good day, discuss. Bye.